Good morning, myself Aruna, Assistant Professor from Department of Physics and Electronics. Today we are doing the experiment on 3 to 8 decoder. So 3 to 8 decoder. So 3 to 8 decoder will have 3 inputs and 8 outputs. So we are going to do it on a trainer kit. This is from 74138 IC is the one which we have used here. It is from Texas company. So 3 inputs are A, B, C and outputs are Y0, Y1, Y2 and up to that from there up to 7 outputs will be there. So this has got control lines. The control lines are G to A, G to B. They are G to A bar and G to B bar. So that they should be connected to ground. And G1 is the another control line. So that should be connected to VCC. So in this board, VCC is 16, which is already connected to plus 5 volts. 8 is ground, that should be connected on. So we will start doing the connections first. So I am connecting A to one of the switches and B to another switch. See, when you are doing the connections, first to switch off the power. Once after the connections are done, check the connections properly, then only switch on the circuit board. So these two short circuit, A connected to switch, B is connected to another switch and C is connected to another switch. So that we can give various input combinations. So we will get 8 combinations. That is the reason this is called 3 to 8 decoder. So G to A, G to B are the control lines, are enable lines. So that I have connected to short circuited and connected to ground. On the board itself there is one ground given. So on that, to that ground I connected that one. So the pin number 8 is an IC ground pin. So that also we connected to ground. Then now left out is G1. G1 is high, should be high. So there is no VCC given on the board. Directly I am connecting to one of the switch and keeping that in a high, so that it is always enabled. So now inputs are done. We are connecting the outputs. Outputs I am connecting to the LEDs. So 8 outputs, 8 LEDs will connect. So the purpose of decoder is we are getting some code that is decoded. So that means let us say that we will get 00 as code. First input will be low, remaining all will be high. So the decoders are used very much in computer circuits, that is on the motherboards. So whatever the address we get from the processor, that should be decoded and given as a chip select to the various chips. So I hope you understand. On the motherboard there will be various ICs. Every IC will have a chip select. So how to select the chip? By means of this decoder. So address is coming from processor. These outputs will go to the chip select of various ICs. So that is the application of this 3 to 8 decoder. So now connections are done. Once again we will check A, B, C inputs we have connected and presently we kept it 0, 0, 0. Next G2 A bar and G2 B bar are connected to ground. G1 is connected to high. 8 pin number 8 is ground, that also connected to ground. So all outputs we connected to LEDs. Now we will switch on. See, now input is 0, 0, 0. So what it decoded? It understood that the only one output should be enabled. So only first output is enabled, that is low, active low, remaining all are active high. So this wire I think is not proper, that's why we are not getting. We will change this one. There is some small loose connection is there. We will change the wire. Yeah, now this is perfect. Okay, now 0, 0, 0 is the input, only first output is low, remaining all are high. Now we will make it 0, 0, 1. See, now immediately the output has shifted to second. That is, second output is enabled, remaining all are disabled. Actually here enabling disabling concept can be high or low. Here it is active low is the enabling concept, that's why it is low. Now we'll make it 0 1 0, third one is low, remaining all are high. Next 0 1 1, so fourth output is high, remaining all are fourth output is low, remaining all are high. Then we'll make it 1 0 0 1 0 0. So now fifth one is enabled, remaining all disabled. Then 1 0 1, it shifted, output has shifted to fifth one. Next 1 0 1 0 1, then we have 1 1 0, this is 1 1 0. Seventh one has become enabled, remaining all are disabled. So now we'll make all high, last one is enabled, remaining all disabled. I hope you understand. You may think high is enabled, low is disabled, but here this is reverse. So in some ICs active low is considered as enabled. So this is done with that concept. So this is called as 3 to 8 decoder. So 3-bit code we are getting, 3-bit code. So that 3-bit code is decoded to 8 outputs. So always decoder will have outputs in powers of 3. So let us say there are 3 inputs, 2 power 3 outputs will be there. So if 4 inputs are there, 16, 2 power 4 is 16 outputs will be there. So this is one experiment, 3 to 8 decoder. Hope you understood this one. So now we'll go for another experiment, that is half adder. We'll go for a half adder. So if you go for the circuit diagram of half adder is a circuit which adds 2 bits. It will add 2 bits and output is sum and carry. Let us say inputs are A, B. Then what are the combinations we'll get? 0, 0. So these are the inputs, 0, 1, 1, 0, 1, 1. So these are the different combinations, possible combinations. So then for each one, what is the sum, what is the carry, we'll check. Sum is 0, 0, anyhow 0, carry also 0. When you add 0 plus 1, sum is 1, carry is 0. 1, 0 if you add, sum is 1, carry is 0. Whereas when you add 1, 1, the answer is 1, 0. That is actually 2. Binary if you convert it is 1, 0. That means sum will keep it 0 and carry will give 1. So if you observe this one, this is sum is exactly like an XOR gate. So we'll use XOR gate for giving the sum, and carry is AND gate, represents the AND gate. So we'll take one XOR gate and we'll take one AND gate and we'll construct the half adder. So A, B are the inputs, A we are getting, B we are getting, that will give it to an XOR gate, so that this is our sum. The same inputs will give it to an AND gate, that will be the carry. So we'll construct the circuit and we'll check the truth table. Okay. Now this is a Physitech trainer board where we have all logic gates. So depending on our experiment, we can use the logic gates. And these are the gates ICs. There are different numbers will be there. All starts with 74 and 7400 is NAND. They are called universal gates. Remaining gates also there will be numbers. You can go through this one. 327432 is OR gate, like that different numbers will be there. Anyhow, it is given already on this board, so it will be easy, but you are taking separately IC and doing on the wish board. You should be careful about the IC numbers, then only you can proceed on. So in one IC there will be 4 AND gates, so they are left out on the board. So for this experiment we require only one AND gate and one XOR gate. So this is an AND gate, first AND gate I am taking. Let us say these first 2 switches will consider as a inputs. So I am giving it to one of the switch. Second input I am giving it to the another switch. So our A, B are this one. So now output is sum. We'll connect it to the LEDs so that we can check the output. Now same inputs, we'll connect it to the XOR gate. So AND gate will give, what it will give? AND gate will give carry, XOR gate will give the sum. So where is XOR gate? This is XOR gate. So we'll connect it to the XOR gate. A we connected, same B also we are connecting it to the XOR gate. Okay. Output of XOR gate will become the carry, sum. XOR gate output is sum. If you want, we'll keep it like this so that so now this is sum. The first LED is going to give the result of sum. Second LED is output we connected to AND gate. So this is going to give the carry. So A, B are the inputs. We'll check now. Both are 0, 0. Anyhow, sum is 0, carry is 0. Now we'll make A 0, B 1. A is 0, B is 1. So now output sum is 1 but carry is 0. Now we'll make it 1, 0. Same. When you make it 1, 0 also, when you add 1, 0 or 0, 1, anyhow sum is 1, carry is 0. But when both are 1, 1, carry will become 1, sum is 0. In position of sum we'll put 0, we'll give that carry to the next bit, next significant bit. So this is the experiment of half adder. So today we did two experiments. One is 3 to 8 decoder, other one is half adder. So both comes under what circuit? Both are combinational logic circuit. So in digital there are two types of circuit, sequential and combination. Both of them are combinational circuits. And also both applications of both are in computers, that is particularly in processors, microprocessors. So in while constructing a microprocessor, so we were giving us in C language and all, you will use some A plus B. So what happens internally? That A plus B will go to this type of circuits. Internally it will go to the circuit called half adder, where they are going to add the bits and it will give the result. So whatever you are writing in software will be done by in hardware. That hardware circuit we have developed here. But there are some limitations with half adder. How many bits it can add? 2. Only 2 bits. But 2 bits are not enough. So you require minimum 3 bits. So 3 bits we require. Why 3 bits? For example, in C language you have given something like 20 plus 30 you have added. 20 is written like this in hexadecimal, let us say I converted. Actually this is not the exact one, just I am roughly writing like this. In some to 8 bits it will be converted, whatever data you give. So you will add least significant bit. So if you add these two, you are getting, let us say 1, 1 is 0 and you are getting some carry. So now for adding the next significant bit, see how many bits are there? 3. So there is a possibility of carry. So but with half adder we cannot do it. So you require a full adder. So if full adder is there, we can add 3 bits. So that is how next we have developed a full adder where we can add 3 bits. So actually it is nothing but combination of 2 half adders. First half adder will construct, will give only AB. Let us say 3 bits you want to add. First 2 bits will add, result plus third bit will add. Same concept here also. So AB will add, whatever sum will get, let us say that is intermediate sum. That will give it to the second half adder. One more bit is there, no, that is carry in, that is the third bit. So whether you get a carry from first half adder or second half adder, you have to get a final carry. So that is given to the OR gate. And second half adder sum is the final sum. So like this we can construct the same circuit by taking 2 half adders, we can construct the full adder. So this is about the half adder and full adder.